All right, class, today we're going to be talking about the metric system. Before we start, please make sure you have your note sheet that I gave you in class. You have a scientific calculator, and you have the conversion factor chart that I gave you in class that shows meters, liters, and grams on it. All right. The way. The metric system is an easy and convenient way to express large and small numbers. It's kind of like scientific notation, but we are using prefixes to represent different powers of 10. What does that mean? Well, if you take a look down here, I know this is hard to see, but these two things are bigger than a base unit. That's like mega and kilo. We can use powers of 10 to represent those. All of these things down here are smaller than a base unit, and we are going to use powers of 10 as well for those. I know it's hard to see them, so we'll just move on. Flip to the next one. This chart is going to be really important to you guys. This shows all of our statements. All right, so you're going to want to copy these down so that you have them. Mega means a million, so 1 megameter is 10 to the 6th meters. We're going to use capital M for mega. Kilometer, that's something you guys should be familiar with. 1 kilometer is 1,000 meters. Now we hit our base unit. Everything below that line is actually smaller than our base unit. So 10 decimeters is 1 meter. 100 centimeters is 1 meter. 1,000 millimeters is 1 meter. And this time we use a lowercase m for milli. Now we've hit micro and we need another m. So what we use is a Greek letter mu for that. Micro is a million. There are 1 million, or 10 to the 6th, micrometers in 1 meter. All right? That is just a Greek letter mu, mu. Nano means a billion. That is 10 to the 9th. So there are 10 to the 9th nanometers in 1 meter. And pico is a trillion, or 10 to the 12th. So there are 10 to the 12th picometers in 1 meter. So this chart right here is very helpful. That's our statements, our conversion statements. The yellow chart takes all of these and makes them into conversion factors. Conversion factors are just one thing that's equal to another over each other. Right? So we're going to use those in an example here in a second. So metric system conversions really involve examining the units to solve the problem. You read the problem, you write down the known, you choose the correct conversion factor, and then you multiply or divide to solve the problem. It's pretty straightforward. So let's take a look at an example here. We're going to do a few of them together, and then you have a homework sheet that you're going to do on your own. So when I look at this first one, it says, how many meters will you walk if you walked 42.31 kilometers? My basic setup is always going to be the known times the conversion factor equals the answer. So when I read this problem, what is the known? Well, the known is the only measured value in the problem. So the known is 42.31 kilometers. What is the conversion factor? Well, this is a little bit trickier. You're going to have to take a look at your conversion chart to see what do I use to solve this problem. So here's my meters table. All right. I know that I'm going from kilometers to meters because it says how many meters. So I go find my kilometers section, and I have to decide which one of these am I going to use to solve this problem. All right? So that's what we're going to identify. I know that the statement that I use comes from up here. So I'm just going to write that down here for now. 1 kilometer is 1,000 meters. And I'm going to decide how I'm going to use that. I'm either going to use it as 1 kilometer over 1,000 meters or 1,000 meters over 1 kilometer. Those are my options. Right, so now let's take a look at how we actually solve that problem. So I'm going to leave this all up here for now. So the solution to the problem, I write down the known, 42.31 kilometers. I'm going to do a conversion to get it into my unknown, which in this case is meters. Over here are my two conversion factors. I have to pick the one that is going to cancel out kilometers. So since kilometers is on the top, I have to use the one that puts kilometers on the bottom. That's the second one right here. I'm going to take that second one and I'm going to write it in there exactly as is. This is always your choice. Which one do you use to solve the problem? You have to use the one that cancels out your known. It's the same as in math. Whatever's on top, if there's the same thing on the bottom, you can cancel it out. Now to solve this, I'm just going to put this in my calculator as is. I'm going to multiply by anything on the top and divide by anything on the bottom. So I'm going to take this as 42.31 times 1,000 divided by 1. I'm going to type that into my calculator and I should get 42,310. Alright, so we're going to try another one here together. Right, you can pause at any time as well to look back. I'm just going to try to get through these kind of quickly since I've recorded this a few times already and I'm sick of it. Alright, so how many micrograms are found in 0.345 grams of aspirin? I start by writing down my known, 0.345 grams. I'm going to do a conversion to get it into my unknown. My unknown always follows the words how many or how much. So I am getting this into micrograms. So now at this point I have to go back to my yellow chart under the grams column and I'm going to pick one of these conversions now, micro. So I have to decide, well, which one is it that I'm going to use? So I'm going to rewrite these out here for you. Right. So I know that 10 to the 6th micrograms is 1 gram. So I have to figure out which way I'm going to write that in here. Well, I want to cancel grams. I have to have grams on the bottom. That means that 10 to the 6th micrograms must go on top. See you tomorrow. And it's that simple. Now I just have to solve it. Now I take 0.345, I multiply by the top, divide by the bottom. So I'm going to multiply by 10 to the 6th, and I'm going to divide by 1. So to type that in the calculator, just to make sure everybody knows how to do that, 0.345 times 10, and you're going to hit the little caret key right down here to the 6th, divided by 1. So that is 345,000 micrograms. They're not always as simple as one step. Sometimes you do get 2 steps in there, so I'm going to do this next one over here for you. Okay. You have to be able to recognize when they are 2 steps. So this question says, how many nanometers are the same as 24.5 kilometers? Well, since I have 2 prefixes, that means this is going to require 2 steps. So I start by writing out my known again, 24.5 kilometers. I know I'm going to have one step that switches it out of kilometers, and then I'm going to have another step that switches it into nanometers. Usually whatever this unit is what you're trying to get rid of, and it's going to go on the bottom here. and whatever this unit is what you're trying to get, and it goes on the top there. So again, I rely on my handy dandy conversion factor chart, and I go looking. I know that I need to cancel out kilometers. So the question is, which one cancels out kilometers, the first one or the second one? Looks like the second one has kilometers on the bottom. So I write in exactly what that conversion factor says. Now I go to the second part. I want to get it into nanometers. So I look on my chart and I find nanometers. I want the one that's going to change it into nanometers. So do I want the first one or the second one? Well, the first one has nanometers on the top. That's what I wanted because meters is going to cancel out that way. Now that I have it all written in, I can type that in on my calculator. It doesn't matter that there's two steps. You're still going to take the top multiplied and the bottom divided. So I'm going to multiply by the top, divide by the bottom. Then I'm going to go on to the next one, multiply by the top, divide by the bottom. So on my calculator, I'm going to do 24.5 times 1,000 divided by 1 times 10 to the 9th divided by 1. And that's going to give me a really big number of 2.45 times 10 to the 13th. Because nanometers are really, really small, that means I must need a lot of them to fill in a kilometer. Alright, and that's how you do the two-step ones. I'm going to do this one right below it here with you too. Alright, you weigh 57.4 decigrams. How many nanograms do you weigh? So I'm going to work this one out kind of fast so that you guys can see. So I'm going to have 57.4 decigrams. It's two steps because I have two prefixes, deci and nano. The first conversion needs to cancel out decigrams. On my chart, 1 gram is 10 decigrams. The second conversion changes it into nanograms. That's the one I just did above. 10 to the 9th nanograms is 1 gram. That cancels out grams. So on my calculator, 57.4 times 1 divided by 10 times 10 to the 9th divided by 1. 57.4 times 1 divided by 10 times 10 to the 9th divided by 1. Oh, I'm going to switch that into scientific notation because that is a lot of zeros. Alright, so I'm going to switch that into scientific notation. 5.74 times 10 to the 9th. Alright. I often get a lot of questions about the ones. Do you need to multiply and divide by the ones? No. As long as you know you're multiplying by the tops, dividing by the bottoms, it doesn't matter. You can leave off the ones because those are not going to change your answer. So that is entirely up to you. I also get a lot of questions about when to put it in scientific notation. My general rule is if I'm going to write more than 3 zeros, I'm probably going to put it in scientific notation. Right? So you might want to as well. So what you guys are going to do is the worksheet that I gave you in class, one side is all one-step problems and the other side is all two-step problems. You do have to show your work. All right, in the same way that I did. I'm just setting up my problems and getting an answer. Setting up my problems and getting an answer. You don't need to show this part where you type in the calculator. All right, I hope that helps. Email me if you have any questions.